1, 2, 1, 2. Excellent. Good. All right, good evening, everyone. So we're going to be talking about streaming tonight, and I'd like to just start off with a quick example of streaming that we'll all be familiar with, which is watching a YouTube video. Now, you can think of, if you click a thumbnail on YouTube, your video just starts playing almost immediately, right? Even if it's a 2-hour, 3-hour video. And that's because it's not had to download the whole thing ahead of time, but it's just downloaded a couple seconds to get you started. And then while you're watching those, it's downloading the next little chunk, and while you're watching those, the next chunk, and so on. So you've only actually ever got a few seconds of the video held in memory or stored on disk at a time. And that brings numerous benefits, like you could watch a really long video, like a 10-hour video or something, on a really memory-constrained device, and it works just as well as it would watching a few-minute video. It also means you can watch a live stream where the video's never actually ended and before you started watching it, but as each chunk gets uploaded, you then download it and you can watch it, whereas if you had to download the whole thing ahead of time, you'd never be able to do that. And those benefits, we're all familiar with them on a YouTube video, but they apply the same to data processing. So that's what we're going to be having a look at today, how to get some of those in Node.js. So I'm Brian Evans, and work at a small business in Waterloo, not far from here, and mainly working with JavaScript, Typescript. And I've been a long-time fan of the Node.js streaming API. I find it often doesn't get quite as much attention as it deserves. As Adam said, it's a really strong point of Node.js. And so we're going to hopefully bring some more light to it today. So the Node.js streaming module is a built-in API in Node.js, and you get loads of powerful tools for free with it without any npm installs. You just get these built in to the runtime, and they provide some great utilities and helpers and constructs for working with processing large data sets in Node.js without ever having to load a whole data set into memory. And you can do things like pipelining and running things concurrently, parallel, and so there's great benefits to it. And to show some of those, I'm going to be doing a live coding demo of 2 scenarios that are kind of somewhat real world, things you've probably come across, but I've kind of simplified them down to show just the core of where streaming comes into it. So the first scenario I'm going to be showing is pagination from the back end. And so that would be like paging through a really big result set in a database like DynamoDB, where you just get a certain amount of items in each batch, but you've got to make multiple requests to get the full data set. So let's jump into that. So I've got a little mock set up for us in VS Code here, where these are the endpoints. Now, as I say, it would apply in Dynamo, but in SQL, it would be like setting an offset in your query and then running multiple queries to go through all the way. And then I've got asynchronous processing function. Now, that could also be saving something to a database or calling a third-party API, anything like that. So to start off with, I'll just log out what this get items is returning. So we can just see what we're dealing with. So if I run node, right. So we've got a batch of items. Adam, I'm so sorry, I've just realized I'm not recording my screen. I'm going to switch that on now. Forgive me. Better late than never. All right. So we've got a batch of items getting returned from that endpoint. And I'm just using some random strings here, but typically those would be like objects or rows in your database coming back. And then we've got a next token, which is the style that DynamoDB uses, where they give a continuation token, and then you send that in each follow-up request so you know where you are in the result set. And then I've just got the page number that we're on just to keep track of that. So the way it will work is if I sent that in the next request. Now we're on page 1, and if I copy that in again, we'd get to page 2, and so on until we reach the end where it would stop returning that token. We know we've got to the end of the data set. So I'll start off just showing, I'm just going to paste this in, just kind of a standard loop way of approaching that if you wanted to apply some processing to every item in the data set. So if we wanted to call that processing function on each one of those results, we could do something like this where we're keeping a mutable token in memory, and I've got a do while loop, so it's just going to run through that once and then continue as long as it's getting another token, and we're just getting that off the response. And then for each item returned, we await processing. So I'll just wrap that with a timer, and then we'll use that as the starting point to improve upon. So I've got 100 items in this data set, 10 items in each batch, and that takes about 7 seconds to do the processing on those 100. Now, you might already notice before we get to streaming, we've got a load of sequential promises running there that don't depend on each other, so we can swap that out for a promise.all and immediately get some performance benefit. So let's do that quickly. So that's just going to send off a whole batch worth of processing and send those off all at the same time and resolve when they've all completed. So that should give us an immediate saving. If we run that, it already looks quicker. And 2.6 seconds, almost 2.7 seconds. So that's cut down a load from the original, but we can still get quicker using the streaming API from Node.js. So first off, the streaming API really works very well with async generators or any kind of generator function in Node.js because it can convert that async iterable into a stream that you can then use with all the streaming helpers that the module provides. So I'll wrap this in a generator function, and I'll do that using the function star syntax. So I've got that little asterisk after function. I'll call that loop through items or something. And so now instead of calling the processing in there, I'll yield that batch up to the caller. And then that's going to allow us to abstract away the processing from this handling of pagination, so we can do the processing in a separate function that doesn't have to concern itself with next token or where you are in the data set. So we can get that out, and that will just send those results up to the calling function into the iterable as each batch is fetched. So then for the actual processing, I'll wrap that in a function as well. I've got a little snippet for that. And just to quickly show how this async generator works, before we put it into a stream, you can do something like this. For await item of loop through items. So this is a special kind of loop where you've got the await in the loop kind of declaration. And yeah, we could have the processing done in there. So let's run that, and we'd expect it to take about the same amount of time. Oh, the timer's out of it there. But anyway, that takes about the same amount of time as it would have in the first go. And then I've just got that in a function that takes the source iterable as its parameter. Now, having these in functions is going to allow us to turn these into streams and then put that into a streaming pipeline. So this is what it would look like, just passing the iterable straight in without turning it into a stream. And let's get the timer back while we're at it. right, all still working. Now, to make this a stream, Node has a brilliant class called Readable, and we can turn this data source into a readable stream where we'll read items off instead of it just being a regular generator. So I'll import Readable from Node stream. And then it's got a static method that can convert from various types of iterators into a readable stream, and that's just readable.from. And now, without changing anything about the processing, we can try running that again. And it's cut it down to 2.1 seconds from 2.6. So we've shaved off about half a second there simply by wrapping it in a readable stream. Now, I wonder if you can see where it's making that saving. Like, what could possibly be quicker about that? What's it doing at the same time? What it is that while it's processing the first batch, if you think so, it'll do the first request and get a batch of 10 items. While it's processing those 10, it's already calling fetch the second batch with that token. And so by the time it finishes processing the first batch, it can immediately begin processing the second batch. So what we've got here is actually, I think, the quickest it can get, because that's just the processing time. All of the batch fetching requests are happening in the background of that. So there's the streaming module, kind of putting those in a pipeline. Now, there's a couple different ways of using the Node Stream module. It's a very comprehensive module, and there's probably at least 5 different ways of using it. And those have evolved over time and developed quite a bit in recent years. So this is one way, using the readable.from. But another function that's been introduced is compose. And compose is a very flexible function that can take all sorts of different parameters and turn them into their streaming equivalent, whether that's a readable stream or writable stream or transform or duplex, etc. So I can run that also with compose, and it should give the same result. Yeah, about 2.1 seconds on there. And then there's a brilliant function called pipeline, which kind of makes the pipeline explicit. And in this case, I've only got 2 steps to the pipeline, so it's not very onerous to just do it how I've got here. But you can imagine a more complicated pipeline where you've got some enriching steps and some destination, and you might have 5 or 6 stages to the pipeline. And then this pipeline function makes it really easy to see the flow of data and what's getting passed where. So we can import that from Node Stream promises, and that will give us a pipeline of when these have finished. So I can pass these as parameters into pipeline one after the other, and it's just going to take the data from the original source, put it through any intermediary steps, and then to the destination. Now in this case it's only 2, but you could have more transforming functions there and just keep adding them on. So I'll run that, and we're getting the same result. As I say, I think that's just about the fastest this can get with the amount of processing time each batch takes. So yeah, that's the end of that little scenario of how we can improve pagination on the back end using streaming. And this is obviously a very small data set, so it's only taking 2 seconds. But you can imagine if these were millions of items and it's taking hours, well then that's quite a substantial saving. The next scenario I'd like to show is compression. So file compression is just how we can squash files down, and it's especially relevant when dealing with big data because it reduces storage space in your S3 bucket and storage usage in your S3 bucket, but also network transfer. If you've got a huge file, you can reduce by compressing it, and quite a common algorithm is gzip. So I've got a CSV file for demonstration purposes that I've gzipped. It's about 400 megabyte file. That gzips down to 70 megabytes, but again, that's just to make it quick enough to demo, but you could imagine that being a 400 gigabyte file or something really massive. And then I've just got a setup script that'll remove it so we can keep rerunning this. So first I'll just write it in the traditional approach we might think of, which would just be read the whole file into memory, unzip it and write it out as a CSV file. So let's do that just using file system APIs in Node. So if we do raw content, read file, and we give it the input path, and then we get the unzipped content with gunzip sync. And then we just write that out to the output file. And I've got a timer on that as well, so we can see how long that's taking. So let's run that. I might just give it a few runs because the file system caches can make it change quite a bit from run to run. So that's doing quite well. It's doing the file in about 1.3 seconds, let's say. And that's reading the whole thing into memory. Now, it's obviously possible to read a 400 megabyte file into memory, but not a 400 gigabyte file. So here we've got the option of doing it the traditional way, where that wouldn't always be the case. So let's now try write this same operation, but using streaming, where we're never at one point having the whole file in memory, but just getting small chunks, unzipping them, and writing them out. And we've only got that small chunk in memory at any one point in time. So instead of awaiting reading the whole file in, we'll make this a read stream. And then instead of getting all the unzipped content, we'll just make an unzipper, which we can create with create gunzip. And then instead of writing the file, we'll make an output stream. Which we can make with the create write stream method that Node.js provides. And then we can use that same pipeline function that we saw in pagination. We can use that to link all of these up and let the data flow between them. So if we start with raw content, pipe that through the unzipper, and then pipe that to the output stream, that gives us quite a convenient way of just waiting for that whole stream to finish. So let's try run that. So it actually takes longer in this example to unzip it, and that's it's not a failed demo. I was aware of that, but for this particular CSV, it does take longer to do it with the streaming mechanism than with loading it all into memory, and I'm not too sure what the underlying reason for that is. But the big benefit of streaming is you could do it on a really big file where you couldn't just read it all into memory, where that isn't an option. But I've got another suggestion, and now this is a bit of a bonus developer tip, not really related to streams, but another suggestion of how we could improve this to get a better runtime, better time to perform the operation, and that is to try switching runtimes. Now, it's maybe a bit controversial to bring to a Node user group, but I'm going to try running it with something not Node, and that is bun. So I'm going to try run the same script with bun, again, with no code changes or anything, and we're getting a substantially quicker runtime. We're getting about 800 milliseconds, which is much quicker than Node's streaming version, and also much quicker than Node's synchronous version. So yeah, there's a little bonus tip. Maybe welcome, maybe unwelcome, but there it is. So yeah, that brings us to the end of the examples, the scenarios that I've got, and I've put all the code from those scenarios in a public Git repo, so you can have a look if you'd like to play around with them yourself or run the different versions of each file. And there's also some further documentation in there. So yeah, have a look. In pagination, I've got a way right at the end here of how you can control concurrency. So here I was just getting batches of 100, but you could imagine if you're getting a batch of 1,000, which DynamoDB can do, but maybe you don't want to overwhelm the API server by sending 1,000 requests at exactly the same second. Maybe it's accessing a SQL database with locks or something. Maybe you only want to send 10 requests at any one point in time. You can use this concurrency parameter in readable.map, and it'll only send that number of promises at a time, but keep them going. And so that can be a really convenient way to control concurrency. And again, it's got a promises API that makes it quite easy to use. So, yep, there's the repo. I hope you all found that useful. And I'll happily take any questions anyone's got on any of those examples or the streaming API in general. Does anyone have anything? Yep.
With this streaming example, how do you manage resources consumed by streaming? I mean, like throughput, which you said, how much memory you can consume at different moment of time or percent.
Sorry, I struggled to hear the first part of your question there.
The question is like, even if you stream data, but you try to stream too fast,
Yeah.
it could get out of resources for you.
Right.
Trying to get big chunks.
Mm-hmm.
You control it.
Yeah, so that's a great question. So it's just if you're streaming and maybe your producer is much faster than your consumer, if processing's taking longer than fetching items, you could run out of memory, right? If that went on for too long. And the way Node.js handles that is something called back pressure, where the consumer can send back pressure to the producer and tell it to slow down if it's not managing to consume items quickly enough. And the great thing is the pipeline function actually manages that. Now you can kind of customize it, and if you build your own streams, you'll have to signal back pressure. But the built-in streams that like create, write stream and so on provide back pressure. So you shouldn't run out of memory even on a very large file if one's faster than the other.
So this is kind of like TCP, like network protocols to handle.
Yeah, perhaps. I'm not very familiar with TCP myself, but if that's what it does, then yeah. There's this great article by Matteo Collina on the Platformatic blog about streams, reading and writing streams, and he goes into some more detail about back pressure. So I've got a link to that in the repository where the consumer can kind of send a signal back to the producer to say, can't take any more data. Any other questions? Well, anyone want to hazard a guess at why the streaming version of that unzip operation took longer than the in-memory one? Anyone have any ideas?
The chunk was too small.
The chunk was too small, right?
Like too much processing needed to handle the small chunks instead of.
Right, like the overhead of chunking it actually outweighed the actual operation, right? Any other ideas?
The same idea.
Yeah.
Garbage collection.
Garbage collection. All right. Well, yeah. As I say, I don't know the answer. Those all sound very realistic. All right. Well, thank you very much. Then that concludes my talk.
Thank you, Brian. And really enjoyed that.
You got it right.